Hi, this is Alex from devstories.eu. Astropy, Python for Astronomy, Episode 8 of 15. The FITS file standard was created in the 1980s for Fortran systems, storing metadata in rigid 80-byte blocks modeled directly after physical punched cards. Dealing with punched card structures in modern code is rarely pleasant. Astropy hides this complexity by translating those blocks into native structures, which is exactly why this episode focuses on demystifying FITS headers and HDUs. Think of a FITS file as a container. Inside this container are header data units, universally known as HDUs. Every FITS file must contain at least one of these, called the primary HDU. Often, this primary unit contains nothing but metadata, while the actual images or binary tables follow directly behind it as extension HDUs. When you open a FITS file using Astropy, it parses this container and gives you back an HDU list object. You navigate this object using standard bracket notation to select individual HDUs. Here is the key insight about indexing. The official FITS standard strictly uses one-based indexing because of its Fortran roots. However, since Astropy is a Python library, it enforces zero-based indexing. The primary HDU is always at index 0, and the first extension is at index 1. It's a simple detail, but forgetting it causes constant off-by-1 errors. Every HDU object contains a header attribute. This is where those old 80-byte blocks live. In FITS terminology, each line of metadata is called a card. A complete card holds a keyword, a value, and sometimes a descriptive comment. Astropy processes these cards and exposes the header to you as an object that acts exactly like a standard Python dictionary. If you need the exposure time, you simply pass the expt keyword to the header. Modifying values works the same way. You assign a new value to the keyword using an equal sign. If you also need to update the comment on that specific card, you assign a tuple containing both the new value and the new comment string. Astropy automatically repacks this data back into the required 80-byte standard behind the scenes. This translation works flawlessly until you encounter legacy data. Older FITS files frequently violate the strict standard. They might feature keywords that are too long or contain illegal characters. Because Astropy strictly validates headers by default, attempting to open a non-compliant file will often raise an exception immediately. Instead of abandoning the file, you can manage this using the verify method. Say you open an old telescope image and hit a validation error regarding the formatting. You capture the file object and call its verify method, passing the string fix argument. Astropy will scan all the header cards, automatically repair formatting issues where possible, and suppress errors for the corrupted fields it fixes. Once the header is stabilized, you can safely update a broken observer card with the correct string and then write your cleaned up HDU list back to disk. Always treat your FITS metadata updates as simple dictionary operations, but keep that verify method ready for the moment legacy data breaks the rules. If you want to help keep the show going, search for DevStoriesEU on Patreon. Thanks for tuning in. Until next time.